Okay, going to introduce the idea of absolute and relative mins and maxes with functions. So here's kind of the big idea between the two. For absolute maxes, what you're going to be paying attention to is when there's a closed interval, meaning it includes the endpoints, and for relative mins and maxes, it's when there's an open interval, meaning you don't look at the endpoints, you look at everything in between. So let's give you an example. So here we have a cubic function. Y is equal to some version of x cubed, right? Well, notice if we look at the endpoints, if we look at this entire part of the graph, we have this point, we have this point, we have this point, and we have this point. Because what we care about is we're going to look at the endpoints and we're going to look at the mins and the maxes, right? So this curve is a max, this curve is a min, but these are the actual endpoints, which in this case, this is the lowest point. So this would be the absolute min. And this is a high point, the highest point in that interval. That's the highest point. So that would be the absolute max. So if you take away, if you say, we only care about the relative mins and maxes, if you take that same graph, we no longer look at the endpoints. The endpoints, here's a better way to do that. The endpoints now we ignore, and all we care about are the terms. So whatever, I'll call that C and I'll call that D. So in this case, a relative max would be at C comma Y, and our relative min would be at D comma its Y. So I'll call that Y1, Y2. So absolute is when you include the endpoints, and relative, right? And the turning points, remember, first day that we talked about derivatives is when the slope of the tangent line is equal to 0. All right, in the next couple of videos, we'll talk about how you find those mins and maxes. All right, that's it for this intro.